This video is about understanding restrictions on acute and obtuse angles and applying properties of vertical angles and linear pairs to find missing values. So first, let's review what an angle is. So remember, an angle is formed by two rays with a common endpoint. So we have one ray right here, and we have another ray going somewhere else, and our common endpoint is this vertex. So our vertex is the common endpoint of the rays. So let's work on naming angles. Make sure when you name an angle that you are naming your angle based on the vertex. So in number one, there's a couple of ways to name this. Number one, we can just name it angle 1, because we can name it by the number that's inside the angle, or we can name it with 3 letters. When you name an angle with 3 letters, make sure that your middle letter is always your vertex. So we can name this angle RAT or angle TAR. In number 2, there's a couple of different angles happening. So the top angle we have right here, we could name that one angle BEA, angle AEB, or angle 1. The bottom angle underneath we have then, this angle right here, we can name that angle AER, angle REA, or we can name it angle 2. The whole angle then is our outside rays, and we can name that in 2 ways as well. We can name it angle BER or angle REB. So let's review that there's 4 types of angles and what types of measures happen. So an acute angle is a smaller angle. An acute angle has a measure that is between 0 and 90 degrees. Right angles have a measure that's equal to 90 degrees. Obtuse angles are greater than 90 degrees, but they are less than 180. And straight angles are formed by straight lines, so they have to be 180 degrees. So we're going to use these restrictions to help us find a variable. So number 1, A is an acute angle. So remember, acute angles have to be between 0 and 90. So when it says, what are the restrictions on angle A? Remember, angle A has to be between 0 and 90 degrees. What are the restrictions on X? So now we're going to take whatever's inside our angle with the X, and we're going to substitute that in for the measure of A, and we're going to solve for X. So when we do that, we get 0 is less than 6x minus 12, which is less than 90. In order to solve for x, whatever we do to one side, we have to do to everything. So I'm going to add 12 on each side of my inequality. So now I have 12 is less than 6x, which is less than 102. And I'm going to divide everything by 6. So 12 divided by 6 means that 2 is less than x, which is less than 102 divided by 6, 17. So that means any value that I pick for x between 2 and 17 will make this an acute angle. So we don't actually know what the total measure of it is. We just know what x values work to make it look like an acute angle when we find the measure. Number 2, in the diagram below, O is obtuse. So remember, obtuse means that you have to be greater than 90 degrees, but less than 180 degrees. So again, we're going to solve for our variable. So it says what restrictions are on y. So we're going to substitute our measure in for the measure of O and solve for y. So 90 is less than 5y plus 20, which is less than 180. So I'm going to subtract 20 from each part of my inequality. 70 is less than 5y, which is less than 160. I'm going to divide each of these by 5. So we get 14 is less than y, which is less than 32. So that means any value between 14 and 32 will make y substituted in to become an obtuse angle. So let's look at some more vocab. Adjacent angles. Adjacent angles are two angles on the same plane with a common vertex and a common side but no common interior points. So for example, if I have an angle here and then an angle next to it, and we call these angle 1 and angle 2, we would say that angle 1 and angle 2 are adjacent. So they're adjacent because they're sharing this common side and the same vertex. Linear pair. Linear pair is a fancy pair of acute angles where the non-common sides are opposite rays. So a linear pair is going to form a straight line. So let's say this is angle 3 and 4. This one down here is a straight line, so it's forming a linear pair. So we can say two things about this. We can say angle 3 and angle 4 are a linear pair. And we can say that the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. Because the non-common side, if this is my common side, the non-common side is forming a straight line. And straight lines always have a measure of 180 degrees. The last vocab then are vertical angles. Vertical angles are non-adjacent angles that are formed by intersecting lines. So if I have two intersecting lines, we could say that angle 5 and angle 6 are vertical angles. So angle 5 and angle 6 are vertical angles. We can also say when they're vertical angles that they are congruent. So angle 5 is congruent to angle 6, which we remember congruent means that their measures are the same. So let's use these ideas to help us find more variables. So number 3, solve for x and find the measure of angle 1. So first I want to solve for x, and I know vertical angles have the same measure, so my vertical angles are congruent. So 5x plus 28 is equal to 8x minus 4. So in order to solve for x, my first step is to subtract 5x from both sides. So 28 is equal to 3x minus 4. Then I'm going to add 4 on both sides. And we get that 3x is equal to 32. Once I solve and get x, I know that x is 32 over 3. Since this doesn't reduce, we're going to leave it as a fraction. Then when I go to find my angle measurement, I'm going to use a calculator just because I have a fraction to deal with. So when I'm using a calculator, I'm going to find one of these two measures first. So let's say we're going to find the 5x plus 28. So 5 times 32 over 3 plus 28. I'm going to put that all into my calculator. So when I put that into my calculator, I get 5 times parenthesis 32 divided by 3 plus 28, which is 81.33. We're going to leave it as a fraction though, so I'm going to do math, enter, enter. 244 over 3 degrees. So that means each of these angles is 244 over 3 degrees. So to find the measure of angle 1, I know that this is a straight line, and straight lines always have a measure of 180. So to find the measure of angle 1, we're going to do 180 minus the measure we just found. So again, in our calculator, 180 minus parenthesis 244 divided by 3. Math, enter, enter. So we get 296 over 3 degrees. Let's try another one. So number 4, again, we have vertical angles on the top and bottom of our picture. So we're going to set those equal because they're congruent. So 13x minus 20 is equal to 2x plus 57. We're going to subtract 2x from both sides. So 11x minus 20 is equal to 57. Add 20 to both sides, so 11x is equal to 77. Divide both sides by 11, so x is equal to 7. So now that I know x is equal to 7, I need to find one of my two angle measurements. So I'm just going to pick the angle on the top, 13 times 7 minus 20. So in my calculator, 13 times 7 minus 20. And I get 71 degrees. So that means this angle is 71 degrees and this angle is 71 degrees. Then to find the measure of angle 1 again, I have a straight line. So the measure of angle 1 is equal to 180 minus 71, which is 109 degrees. So angle 1 has a measure of 109 degrees. Number 5, solve for M, N, and P. So first let's look and see if we have any angles that form a straight line. So I know that there's a straight line right here, which will help me find P. So to find P, it's 180 minus 141, which gets me 39 degrees. Then I can also notice with this other line, I now have two intersecting lines, which means that P and N are vertical angles, so they have the same measure of 39 degrees. And then I can go back to that straight line that I started. So to get M, I know two of the angle measurements, so I can subtract them from 180 to get my third angle measure. So 180 minus 43 minus 39 means that M is 98 degrees. Solve the following problems using linear pairs. So in this case, they're telling us that BEA is 5x plus 19, and that EAS is 10x minus 4. So they're forming a straight line together, and straight lines always have measures of 180. So to solve for x, we're going to add these two angles together and set it equal to 180. So when I combine like terms, 15x plus 15 equals 180. We can subtract 15 from both sides, so 15x equals 65, 165. And when I divide by 15, we get that x is 11. In number 7, we know that HWA is 31 plus x squared. AWK is 50 minus x. And KWS is negative 3 minus 10x. So in this case, all three of these angles together are going to form a straight line, which means that they're all equal to 180 when they're added together. So we have 31 plus x squared plus 50 minus x minus 3 minus 10x equals 180. Before I do anything, I want to combine like terms. So I'm left with x squared. My x's combine to become minus 11x. And my numbers combine, 31 plus 50 minus 3, to become 78, which is equal to 180. Now I see an x squared, so I'm going to subtract 180 from both sides. So when I do that, I get x squared minus 11x minus 102 equals 0. So I need two numbers that multiply to 102 and add to negative 11. So I get x minus 17 and x plus 6 equals 0. So when I solve, I have to flip my sign, so x is 17 and x is negative 6. When I go to put negative 6 in to both of my angles, 50 minus negative 6 is a positive. Negative 3 minus 10 times negative 6 is also a positive. So x equals negative 6 is actually the solution. While if I put 17 in, I would get a negative angle measure here, and I can't have negative angle measures. So x would not be equal to 16 in this equal to 17 in this situation.